Welcome to this lesson on area of triangles. Let's make sure we have these notes in front of you so we can begin our lesson. And my students, let's make sure we update our table of contents. The learning objective for today says I can solve triangle area problems. So let's go ahead and talk about three different types of triangles. And by the way, triangles are polygons with three sides. The first triangle is a right triangle. And a right triangle is known because it has a 90-degree box at the corner. So whenever we have a right triangle, they're giving us a base and a height. And notice the base and the height both touch the 90-degree box. And that's how you know you have the base and the height. The third line of the triangle is neither the base or the height because it does not touch the 90-degree box. So if you want to find the area of a right triangle, you can use this formula. Area is equal to 1/2 times the base times the height. Sometimes an easier formula to use would be this. Area is equal to base times height divided by 2. Please know that both of these formulas are the same, and you can choose which one you want to use. The second type of triangle is called acute triangles. And acute triangles have angles that are less than 90 degrees. So this is less than 90 degrees, this angle is less than 90 degrees, and this angle is less than 90 degrees. Notice that this problem does not have a 90-degree box, but what we can do is we can go ahead and create one. We can create a height by taking the top of the triangle and drawing a nice straight line all the way down to the very bottom of the last side of the triangle, and we can make a 90-degree box here. This is the height of the triangle because that's how tall the triangle is. The bottom of the triangle would be the base. Notice the base and the height both touch the 90-degree box. These sides are not the base and the height, so we don't use them. Those sides do not touch the 90-degree box. So if we want to find the area of this triangle, we can go ahead and use this formula. Area is equal to 1/2 times the base times the height. Or another one would be area equals base times height divided by 2. These are the same formulas. And notice that the formula for finding the area of a right triangle and an acute triangle is the same. So now let's talk about an obtuse triangle. An obtuse triangle has angles that are, at least one angle that is more than 90 degrees. So this angle right here would be greater than 90 degrees. This one's less than 90 degrees. This one's less than 90 degrees. So let's go ahead and take a look at what we have. We do not have a 90-degree box, but what we can do is we can assume that this line goes on, and we can assume that the height of the triangle can go this way. What happens is we form a 90-degree box going. So this becomes our height, and our base would be this right here. Notice the dashed line both touches the 90-degree box, which means this is our base and this is our height. This line right here does not touch the 90-degree box, so we don't use it. So let's go ahead and take a look at our formula. We can also use area equals 1/2 times the base times the height. Or you can use area equals base times height divided by 2. So let's use these key concepts to discuss the following examples. So why is the area formula of a triangle similar to the area formula of a rectangle? Let's take a look at this. In one of these grids, let's go ahead and draw a rectangle like this. And in the second grid, let's go ahead and draw the same exact rectangle again. So we know from a previous concept or lesson that we know that the area of a rectangle is the base times the height. Now if you look at the second grid, what we can do is we can take that same exact rectangle, but let's go ahead and cut it in half. Notice we now have two triangles. So I can say the area of this side would be the area is equal to base times height, but let's divide it by 2 because I have two sides and I cut it in half. And this side would also be area is equal to base times height, but let's divide it by 2. So that's pretty much where the area formula comes from, because you're cutting a rectangle into two pieces. So for example, when it says find the area of the triangle. So let's write our formula first. Let's use area equals 1/2 times the base times the height. And let's identify our base. Our base would be right here, and we have to count. Here's 1, 2, 3, 4, 5, 6. Our base is 6 units long, and our height is equal to 1, 2, 3, 4 units tall. So let's plug this information into our formula. Area is equal to 1/2 times the base, which is 6, times the height, which is 4. So let's go ahead and multiply 1/2 times 6 times 4, which is 24. And I can multiply fractions by placing a 1 under my 24. Now let's go ahead and solve this again. Area is equal to, if I multiply my numerators, I get 24 on the top. If I multiply by denominators, I get 2 on the bottom. And I can simplify that further. Area is equal to 12 units squared. And that's the area of this triangle. If you go ahead and count all the blue squares that are inside of this triangle, you're going to find that you have 12 units of those blue squares as well. For example 2, it says the front of a camping tent has the dimensions shown. How much material was used to make the front of the tent? So in this problem, here's the triangle that they're giving us. I'm going to use the area is equal to base times height divided by 2 formula. Now I could choose to use the other one with the 1/2, but I want to use this one just to show you how they work. So let's go ahead and identify our information. The base would be the 5, and the height would be the 3. Notice the base and the height both touch the 90-degree box. So let's plug this into our formula. Area is equal to 5 times 3 divided by 2. Let's solve. On the top we have 15, and on the denominator we have 2. So the area is 15 divided by 2 is 7.5, or 7.5 feet squared. So if we were to use the other formula, area equals 1/2 times base times height, we would get the same exact answer. For example 3, it says find the area of the triangle. So let's go ahead and write area equals 1/2 times the base times the height. And let's take a look at the information that we have. We have a base, which is this bottom line right here, because it extends out. So that's 15 6/10. And our height, it's not this slanted side, it's the one that stands straight and tall up and down, and it also touches the 90-degree box. So our height is equal to 11.25. So let's go ahead and plug these items inside of our formula. Area is equal to 1/2 times our base, which is 15.6, times our height, which is 11.25. So let's go ahead and multiply these numbers. If I multiply 15.6 times 11.25, I get 175.5. Then I have to multiply that with 1/2. I can make this look like a fraction, so let's multiply the numerator. So 1 times 175.5 would be 175.5. And on the bottom we would have 2. And we can divide 175.5 divided by 2, and we get 87.75 meters squared. If you were to use the area equals base times height divided by 2 formula, you would still get the same exact answer. So pause the video, complete these Got It problems, and we'll discuss the answer in class tomorrow. Notice we have 2 Got It problems on this slide, Got It problem A and Got It problem B. And you should try using each of the different formulas for finding the area of a triangle for these Got It problems, just so you can have more experience with it. For example 4, it says find the missing dimension of the triangle. For this problem, they're asking us to work backwards because instead of finding the area, they're already given us the area. So let's go ahead and take a look at this formula. Let's use area equals base times height divided by 2. And let's find out the information that we have. Our base, they're calling it B. So I don't know what B is, so I'm going to use B for base. And for height, it's going to be 6 centimeters because it's touching the 90-degree box or 90-degree angle, so our height is 6 centimeters. Let's go ahead and plug the information into this problem. Our area is equal to 24 centimeters, and our base is B, and our height is 6, and we have to divide it by 2. Alright, so let's go ahead and solve this problem. To isolate the variable, let's actually go ahead and draw our fulcrum down the center of the equal sign. And let's get rid of this 2 on the bottom, so let's, instead of dividing by 2, let's multiply by 2 over 1. But I have to make sure I do it to both sides to keep it balanced. That's an example of using the multiplication property of equality. So on the left-hand side, we have 48. And we can drop down the rest of it, which is B times 6. So now we can isolate this variable by, instead of multiplying by 6, let's divide by 6 so that B can be by itself. And we can cross out the 6's. Now B is alone. Now 48 divided by 6 is equal to 8. So the base of the rectangle, or the triangle, is 8 centimeters long. So pause the video and complete this guided problem, and we'll discuss the answer in class tomorrow. So pause the video and complete this guided problem, and we'll discuss the answer in class tomorrow. So we've just completed the lesson. Go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.